Well, how's it going, everybody? We are learning today to work with geometric series, section 6.6 in your textbook. We've been working with arithmetic series, switching it up a little bit. You're, in this video, going to learn how to use a formula to solve problems involving the sum of a finite geometric series. Now, with arithmetic series, all we ever found the sum of was a finite series, and it would make sense that that's all you could do, but we're actually going to look at how you can sometimes find sums of infinite geometric series in another video. Alright, but on to the finite geometric series here. Now, there's not going to be a cool way of deriving this formula that we need to take the time to address right here. What I need to basically do is just tell you the formula, the two different versions of the formula that help you to find the sum of the first n terms of a finite geometric series. Okay. If you're going to find the sum of the first n terms of a geometric series, you're going to need to know the first term. You're going to need to know the common ratio. All right, and if you know both of those things, then you can use either this version of the formula or this version of the formula down there. So here we do the first term times the difference of the common ratio to the nth power minus 1, and then we divide by 1 less than the common ratio. Alright, now this is useful for whenever the common ratio is greater than 1. That ensures that you're dividing by a positive value down here. The other version of the formula is the one that's going to apply to something else we do later on. You see that the only difference is that instead of r to the nth minus 1, we have 1 minus r to the nth, and the order of the subtraction changed in the denominator as well to 1 minus r. Alright, first term, common ratio. If you know those two things, you can find the sum of a finite geometric series. So let's practice that. Here what we're going to do is we're going to calculate s sub 8, the sum of the first 8 terms for this geometric series. Now, when we're trying to find the sum of the first 8 terms in this geometric series, one of the things that's kind of interesting is that you don't even have to know what the 8th term is. We had to know the first and last term with the arithmetic series. Only the first term and the common ratio are necessary here. Okay, so we're going to do u sub 1, which is 4, times the common ratio to the nth power minus 1 over the common ratio minus 1. Now, I mentioned to you between these two formulas here that you use this one generally whenever the common ratio is greater than 1, and you tend to use this one whenever the common ratio is less than 1 so that you're dividing by a positive value. Well, if the terms are increasing in value, I already know that r is going to be greater than 1, don't I? And what exactly is r? Well, 6 divided by 4 is 1.5, 9 divided by 6 is 1.5. The common ratio is going to be 1.5. So we'll have 4 times 1.5 to the 8th power, because n was 8 if we're calculating for 8 terms, minus 1, divided by the common ratio, minus 1. Now, whenever you're using this formula, it's almost always going to be a calculator exercise. I don't expect you to be able to raise 1.5 to the 8th power without that. So use your calculator, and let's go ahead and approximate this to 3 significant figures. In so doing, we're going to find out that the sum of the first 8 terms in this series is 197, approximately. Alright, so can you use a formula? Great. You can find the sum of the terms in a finite geometric series. This is a formula, by the way, that your formula booklet will give you for your IB exams, and so we'll have that in class as well. Let's get that example. It's kind of too similar to the one we just did. All right, now, going to look at kind of another spin on this whole thing, finding the sum. In this problem, it's a geometric series, right? We're going to have to find out how many terms there are in this series before we can calculate the sum. I guess there was one thing I didn't tell you, or I didn't mention whenever I was saying what you need. You need to know the common ratio, you need to know the first term, but you also have to know how many terms if you're going to calculate the sum of a finite geometric series. So, our task here is to first find out which term in this geometric series 24.8832 is. And then once we figure that out, then we can just use that formula that we used a moment ago to find the sum. And we'll find out what the term number is using the general formula for a geometric sequence, of course. Remember, u sub n equals u sub 1 times the common ratio to the n minus first power. And we're calling 24.8832, the use of n. So substitute, you're going to have 24.8832 equals the first term, 10, times the common ratio to the n minus first power. And the common ratio, 12 divided by 10 is 1.2, 14.4 divided by 12 is 1.2. Common ratio is 1.2. All right, now to solve this equation, we are going to use logarithms here in a moment. I'm going to go ahead and divide both sides by 10 to start off. So that will give me 2.48832 equals 1.2 to the n minus first power. All right, now we'll take the log of both sides, common logarithm, natural logarithm, whatever you choose. I'm going to go natural logs in this case. And I'm going to go ahead and also use the power property when I do this. I'm going to bring the exponent and make it a coefficient for the logarithm. All right, and just a couple more steps to get n by itself. We're going to divide both sides by the natural log of 1.2, and then we're going to have to add 1. And so that'll end up giving us that n is equal to the natural log, 2.48832, divided by the natural log of 1.2, and then plus 1 to finish getting n by itself. Use your calculator and evaluate that. It's got to come out to an integer, right? Or a whole number, in fact, positive whole number, because n is the term number. And indeed, when you use your calculator to simplify, this whole mess right there becomes 5 plus 1, so 6. Meaning that we're trying to find the sum of the first six terms of this series. So now use your formula. S sub 6 equals the first term 10 all right, times, and common ratio is greater than 1, we said, so I'll use that r to the n minus 1 formula. So times 1.2 to the 6th power minus 1 over 1.2, the common ratio, minus 1. Again, just use your calculator and simplify. Approximate to 3 significant figures. All right, you got 99.3, I hope, because that is the sum. Great. I've got one more example that I want us to try that's pretty much like this one right here. I'll go ahead and put it on the screen right now. The only difference is that the terms in the sequence happen to have variables. They don't happen to have numbers, but it works exactly the same way. So I'd like, if you understood the previous example, for you to try this one on your own. If you didn't, keep watching, and at whatever point you feel confident proceeding without me, go ahead and do so, please. All right, now it's a little bit tough to see that this is a geometric series whenever you're just thinking about, well, I've got all these variables in this sequence. You know, what kind of pattern could I possibly have going on right there? But you're going to notice how you get from one term to the next, I hope. If you go from p to pq squared, that means you multiplied the first term by q squared. And if you multiply that by q squared, don't you get pq to the 4th? All right, and so eventually if we keep multiplying by q squares, it makes sense that we would get to pq to the 16th power. All right, our common ratio is q squared, and you would have figured that out just by dividing any term by its previous term. The p's would have canceled, and you would have had like q to the 4th divided by q to the 2nd is q to the 2nd, for instance. All right, common ratio, we know. But we don't know, again, what term this is right here. So, going to have to do a little bit of algebra to figure that out. Alright, so we're using the general formula, u sub n equals u sub 1 times r to the n minus first power. And that means we're going to have pq to the 16th power equals p times the common ratio q squared to the n minus first power. Now how we're going to solve that equation for n? Well, we will use logarithms, but let's do as we did last time, and let's go ahead and divide both sides by this value to begin. That'll give us q to the 16th power equals q squared to the n minus first power. And we could use logarithms again. If you want to, you can rewrite both sides of the equation so that they have the same base, right? They both have q. Like you can make this right side of the left side of the equation, excuse me, into q squared to the 8th power equals q squared to the n minus first power. And then since the q squared parts are the same, that means that n minus 1 right there has to be equal to 8. And if n minus 1 is equal to 8, then you know that n is equal to 9. So that's the 9th term. We know that's the 9th term now. So then finally use your formula and find the sum of the first 9 terms. That'll look like this. You'll have p times q squared to the 9th power minus 1 divided by q squared minus 1. Alright, and then just do a little bit of simplification there, right? In the parentheses here, you're going to get q to the 18th power minus 1. And then if you distribute p, that will give you pq to the 18th power minus p over q squared minus 1. That's how you find the sum of a finite geometric series. Thanks for watching. We'll have another video in this section, and then we'll work on infinite series after that. See ya.